at our topology diagram, we choose an extended star topology. So in the middle, we have a HQ router, and from there we connect all the four networks together. The HQ network, northern branch, southern branch, and the central data center. And each network has its own switch and extended star topology to connect all the wired and wireless devices together. Centralized management. All networks connected together through one central HQ router in the middle, and this makes it easier for us to monitor, manage, and control the whole network from a central point. The second one is scalability. If the company expands in the future, we can easily add more branches or devices without changing the whole network structure. And lastly is fault isolation. If one branch or switch has a problem, the rest of the network will still function normally, and this makes troubleshooting and maintenance more efficient. So overall, this topology is reliable, simple to manage, and suitable for a growing company like InnoTech.
The device we need to use is 2 network printers, 5 desktop PCs, and 5 wireless laptops. The requirement is first, printers and PCs must be connected via wired internet to the HQ switch. And second, laptops must connect wirelessly via an access
we
point.
will be connected to HQ switch via port for Ethernet 00. And HQ switch will be used 9 port. First, we will ping within a branch. We will use ping PC1 to PC3. Ping 192.168.2012. All packets successful sent. Next, we will ping ping1, ping 192.168.2020. And lastly, we will ping laptop. Next, we will ping PC2 ping 192.168 PC4 to 54. Soft PC2 and all packets are successful sent. And next, we will ping HQ laptop 4 to North laptop 1. Next, we will send email to other branch. We will send to North branch using email north1@innotech.com, and the subject is payroll. Then
As for the northern network,
we will
subnet
check
as given is
the email received.
192.168.30.0/24, and the devices needed are a printer, 2 desktop PCs, and 2 wireless laptops. And the requirements are all wired devices connect through the northern branch switch, and laptops access the network via a wireless access point. As you can see from the picture between devices in the northern branch, all the requirements are those pinging tests are successful between the PC and the laptop, and then between the laptop and the printer inside the testing pinging between different branches. So you can see that the northern laptop can ping successfully to the southern laptop, and the northern laptop can successfully ping the HQ testing for DNS server and HTTPS server. Lastly, the FTP server. Yeah, as you can see from the picture.
So now I'm going to continue with the southern network. So this LAN uses the 192.168.40.0 over 24 subnet and includes 2 PCs, 1 printer, and 3 wireless laptops connected through an access point. All IP addresses for the laptops are automatically assigned via the HTTP. From the picture, we can see the topology of this local area network. We can see the southern switch and the access point connects to the switch to serve wireless laptops. Moving on to the IP configuration for each devices, we can see the configuration for both the access point and the laptop. So based on this picture, we can see that the laptop is connected to the Southern Wi-Fi SSID and successfully receives an IP via the HTTP, confirming the wireless and devices in the Southern branch. I have assigned static IP addresses to ensure consistent and reliable addressing. Here you can see that interface Gigabyte 9 over 0 is configured with IP 192.168.40.11. EC2 uses 192.168.40.12 is set up to assign IPs and the printer is assigned on 192.168.40.13. All devices share the same subnet mask, and the default gateway is set to 192.168.40.1, which matches the router's interface. I will now try pinging the HQ router interface at 192.168.20.1.
I will test connectivity by pinging the default gateway
inter-branch routing is working between the southern branch and HQ. The successful reply confirms that the device is able to communicate with the router, which is essential for accessing other networks. After typing the ping commands to the default gateway, based on the picture, we can see there are replies which indicate successful communication. In this part, this is how a wireless laptop in the southern branch sends an email to a device in the northern branch using the email server hosted in the data center. This demonstrates how devices from different networks can communicate and benefit from the email client on the northern laptop one. I have configured the email client on the southern laptop mine to use the data center's email server at 192.168.
And I configured
This
file
confirms
servers
that
using
wireless
both
both
ITC
incoming and
and
outgoing
DNS server
routing
for
and
name
centralized
resolution,
email
the web
services
server
to the northern
HTTP
branch
for
are
public
working
website,
as
the
expected.
secure web server HTTPS for secure login portal, the FTP server for file sharing, and the email server for staff email communication. And all the servers are connected to switch network, and the DNS is set to 192.168.50.14 to support the domain names like www.inotech.com. So now I will explain how I test the data center servers to make sure they function properly in our network. So first, I open any PC or laptop in our network and go to the web browser and type www.inotech.com. The homepage appears successfully, and this shows that our HTTP server is running, and also prove that the DNS server is working because the domain name was successfully resolved into the correct IP address. And I also edit the HTML file on the web server, also the secure web server, to include a custom page for representing our company's public website and secure login
I
portal.
log in using FTP credentials, and as you can see in the screenshot, it successfully logged in and displayed a list of files from the server. This confirms that the FTP service is active, reachable from the network, and functioning as expected. But just a note, in Cisco Packet Tracer, the FTP is only simulation, so the actual file transfers like upload or download will not happen. But the login and file listing prove that the configuration works well.
Of a complete local area network LAN infrastructure for a growing company by using Cisco Packet Tracer. The network is divided by four mains, which is headquarters, northern branch, southern branch, and the central data center, each configured with appropriate IP addressing schemes and devices. Key networking principles such as subnetting, device configuration, and wireless connectivity were applied effectively. The setup met all
And here's what I configure for each of the servers.
integration and server configuration for web and FTP services. The use of a central HQ router ensured seamless internet interconnectivity among all subnets. This project has boosted our practical understanding of network planning, topology designing, and troubleshooting. It also reinforced the importance of organizing network documentation and systematic implementation for scalability and maintenance. Overall, the activity provided us a valuable hands-on experience in building a real-world LAN environment.